Okay, now we're going to solve some more triangles. The first one I have here is I'm given 3 sides and I'm asked to find the 3 angles. So this would be a law of cosines problem using the side formulas. So to start with, we'll start with alpha. So cosine of alpha is equal to, it's always a fraction. If you're trying to find alpha, you use the 2 sides next to it first. So you'd say 5 squared plus 8 squared minus the opposite side, which would be 7 squared, divided by 2 times 5 times 8. 2 is just part of the formula, and you always use the 5 and the 8. Now, the trick is typing it in your calculator. Okay, you do the entire numerator first. So I go 5 squared plus 8 squared minus 7 squared, and then I hit enter. And then divided by, and then you put parentheses. You have to include the parentheses. 2 times 5 times 8. Now, of course, some of you could actually know that that was 80 and just think 80, but you know, we can just type it in the way it is. And then I hit enter. And so then, because that's what the cosine of alpha is equal to figure out, so officially it would be, you could say, cosine of alpha is equal to 0.5, okay? So then I'm just going to go second cosine, second answer. And so it tells me that alpha is equal to 60 degrees. Alpha is equal to 60 degrees. So I'm going to go ahead and write that in, okay? Next, I'm going to go ahead and find beta. So I could say the cosine of beta is equal to, and so when I'm trying to find beta, I'm concentrating on these 2 sides first. So it'd be 7 squared plus 8 squared minus 5 squared divided by 2 times 7 times 8. So then I type that in my calculator. I would say 7 squared plus 8 squared minus 5 squared. I always go ahead and hit enter at this point. Divided by the denominator, and you need to put in parentheses, 2 times 7 times 8. And so I get really that the cosine of beta is equal to 0.7857. And so then that's what cosine of beta is. And to figure out what beta is, you kind of use the angle finder button, the second key. So you go second cosine, second answer. I could have typed in second cosine 0.7857, but it's still easier to go second answer. And I get that beta is 38.21 degrees. One benefit to using law of cosines is there are no ambiguous cases. There's not like, oh, I wonder if this could be something else. It can't be anything else. And then in order to find gamma, I would just say 180 minus 60 minus 38.21. And I get that gamma is 81.79 degrees. So we solved for all 3 angles. All right, next I have another situation here. They didn't give me a picture. Not all the problems on your test will they give you a picture. So in this case, they tell me that side A is 22, side B is 6, and angle beta is 14 degrees. So to start with, I know B and beta, so I know already I can use law of sines to figure this out. So since they told me side A, I think I'm going to find side alpha first. So I would say the sine of alpha over A, and A is 22, is equal to the sine of 14 degrees over 6, sine of beta over 6, okay? Then we cross multiply, so I get 6 times the sine of alpha is equal to 22 times the sine of 14 degrees. I just divide both sides by 6. So in my calculator, I just go ahead and type in, so this will tell me what sine of alpha is equal to. So I go 22 times the sine of 14 divided by 6, and so I get 0.8870. I know that sine is positive in the first and second quadrants. So when I go second sine, second answer, it's going to give me the first quadrant answer. To figure out the second quadrant, I'll just say 180 minus that to figure out the second quadrant one. So I'm going to go second sine, second answer, and I get 62.5 0.50 degrees, okay? And then to find the other one, I'm going to go 180 minus that answer, and that gives me 117.50 degrees. Okay, to decide whether you can use this second obtuse angle, you just look at the angle they gave us. They told us beta was 14 degrees. If you added it to 117.5, does that exceed 180? And no, it does not. So that means I'm going to have two cases here. So I know that alpha is either 62.50 degrees or alpha is 117.50 degrees. So I'm going to go ahead and just put a line down here. But these will be my, for C, I already have them for alpha and for gamma. So to start with, let's go ahead and find our gamma for both cases. To figure out this triangle here, I'm just going to say 180 minus 14 minus 62.5, and that lets me know that in this case gamma is 103.50 degrees. Then I'm going to do the same thing over here. I'm going to say 180 minus 14 minus 117.5, and that lets me know that gamma in this case is 48.50 degrees. Alright, so now all I have to do is I need to solve for C. So to solve for C, I'm going to use law of sines. So I'm going to say the sine of 14 over 6 is equal to, since gamma is opposite C, I'll use that. So I say the sine of 103.5 over C, and I cross multiply, so you get C times sine of 14 is equal to 6 times the sine of 103.5, and we'll just divide both sides by sine of 14 degrees. And we'll get C is equal to 6 times the sine of 103.5, enter, divided by sine of 14, enter, and so I get that C is 24.12. 24.12. Alright, this should be the biggest one, because notice this side's 6, this side's 22, this side's 24.12, but it's opposite the largest angle, 103.5 degrees. Alright, and then to figure out my other triangle, I just need to use law of sines again. So I'm going to say the sine of 14 over 6 is equal to now the sine of this gamma, which is 48.5 over C. And we cross multiply again, divide by sine of 14. So I'm just going to do that. 6 times sine of 48.5, enter, divided by sine of 14. And in this case, I get that C is equal to 18.58. 18.58. And is it reasonable that it would be smaller? Yes, because the angle is smaller here. So the largest side has to be alpha, because this is the largest angle. So 22 is the biggest side, then 18.58, then 6. So that kind of makes sense. So this would be our law of sines, where you have two possible triangles possible.